Hey, welcome to a special edition of Math That Matters. I wanted to talk about exam 2 in just a short video here. So we took exam 2 last Friday. Today's Easter Sunday. And I got them all graded by, I guess, Saturday morning. So I spent quite a bit of time on that. And I will say that I probably put in more effort into this unit as a teacher than just about anything I've done in 27 years of teaching. And what's really hard to swallow is when you try really hard at something and it doesn't go well. So it really, for the most part, didn't go that great. And I thought that I had seen people do things even in my office that they didn't do well on the exam. So it was a difficult evening, I guess, and morning. The morning was better because I prayed about it and I slept on it. And I was just thinking about in life, a lot of times you try really hard and the easy thing once you try really hard is to say, that'll be good enough because trying hard is all that matters. But sometimes you try really hard and things don't go well. And so you have to get better. You have to learn more. And I was trying to think about what should I do to help you guys out, because I do care a lot. I care about how you do. I care about you as people. And I want to do a good job on my end of things as well. So I was just thinking, well, I could curve the test. And if you curve the test, then you sort of throw out a whole bunch of points. And that didn't seem like the gracious thing to do. You know, sometimes people just think grace is getting off the hook. And I think grace, if you look at the Bible, scripturally, grace is depicted as a power. It's more than just getting off the hook. It's being given not only another chance, but it's being given the power to succeed. The Apostle Paul says, I have this thing, it's this thorn in my flesh. I want it gone, I want it gone, I want it gone. And God says, no. 3 times he says, my grace is sufficient for you, for my power is made perfect in weakness. So what I'm going to do for you guys, and so that I can own whatever part of this not as good of a performance as I had hoped for, and you as well, is I'm going to give you a 5-question chance to make up 25 points on your exam. So that's a pretty significant chunk of points. There were 5 types of questions on the exam that I thought were really, really, I guess, doable. And for whatever reason, they didn't go that well. So I'm going to go through the exam in just a minute here on this video, but I'm also going to show you, I'm going to share my screen here, what I want to do with all of this. So here's the way in which you can make up to 25 test points back on your exam. So these are like kind of bonus points. They just go toward your score. It's like 25 out of 0 up to a maximum of 105%. So some people are going to get capped out because they were within 25% of 105. But basically, I figured out that there were kind of 5 fundamental questions from this logic unit that people had a lot of trouble with. And so I'm going to give you in an office hour these 5 questions this week, and you can come in, and if you can do these 5 questions, you can get up to 25 test points back. But in order to qualify to do this, I've given you 5 questions here on this worksheet. This is going to be on Foxtail that kind of mirror them. So it's like almost a practice test. You just need to make sure that you learn how to do this stuff before you come in to take that makeup point exam. And you can see there's a link here on this sheet that you'll click on, and it'll just take you to a spreadsheet. And I just want you to sign up for one of these office hours to come in, bring in your 5 qualifying problems, and then I'll give you a 5-question exam, and hopefully you'll make up all those 25 points. So you can see I've got some different times all the days of the week, and we'll get Neil to put some times here. I think he may want to help me out with this as well. So what were the 5 kinds of questions that didn't go that well that I thought should have gone well? That in a logic unit, people have to know how to do these things. So the first one was negating statements. There was just a lot of problems with negating statements. We were trying to negate ands and ors, and people were negating ands with new ands, and that's not the way it works. People were negating conditional statements with new conditional statements. If P, then Q. Negate that, and we were not getting P and not Q. We were getting new if then. So we got to go back. We got to try harder, right? We got to do better. It sucks, when you try really hard, and I know some of you tried really hard on this test, and I tried really hard as a teacher, and when you get results that aren't good enough, when you've tried really hard, it hurts. But that's okay, you know. It's just often the case that the first time you try something, you have trouble. And so that's okay. We're going to do the best we can to dig a little bit out of this. So the first question will be on negating statements. I'll give you some statements like on the exam. You'll have to negate them. The second one is a truth table proving logical equivalence, including the part where you say that, quote, since all the truth values in one column match all the truth values in another column, the column headings are equivalent. That's a part of the proof when you're showing two things are logically equivalent. So you're going to get one of those. You're going to get a second truth table to validate or invalidate an argument, including the part where you identify the critical rows and you say, hey, in all the critical rows, the conclusion is true, therefore it's valid. Or in this critical row or another, there's a conclusion that's false, therefore the argument is invalid. The fourth one will be a logic proof. You'll need to go through step by step, showing me that you can walk from some given premises to a particular conclusion, making sure to include the reasons accompanying your steps that you create, as well as the row numbers the reasons make use of. And then the final thing, the fifth question, will be identifying necessary and sufficient conditions given tables of candidates and targets. And you can see that down below, this is your qualifying assignment. So I'm just giving you some different statements to negate and practice that. And then you're going to do something just like that on the makeup points exam. Here's construct a truth table showing equivalence. Construct a truth table testing the validity of this argument. Here's a proof. So you have to take these premises 1, 2, and 3, and you have to walk down to this conclusion. So again, this is the qualifying assignment, but you'll have something very much like this when you make up your 25 points. And then finally, you'll have these candidates, A, B, C, and D, or whatever, and some target, and you'll look for necessary and sufficient conditions. So let's take a look actually at the key to the exam. I'm not going to go through every single part of this, but you'll see the whole part, the whole exam, and you'll see all of the correct answers. You can always pause the video and you can take a look to see what maybe you got correct and what you didn't get correct. And there were a few problems where I gave some leniency, like letter E here, the 7 explanatory virtues. Sometimes there was a little bit of overlap, and so I picked conservativeness for this one. I thought that was the best answer, but certainly there were some other ones that were legitimate, and I gave some credit for that too. But you can see what the solutions are here for the fill in the blanks vocabulary. The negations are pretty important, so let's talk about that. So to negate tall and fast, like if you had T and F, the negation of that is just De Morgan's law. So you would say not tall or not fast. You have to get an or when you negate an and statement. And notice I'm picking statements that are pieces that are opposite. So tall's opposite is short. I didn't write not tall. And it's kind of better if you don't write not, if there's a direct word that kind of means the opposite. Hot or spicy. If you negate that, you get an and. And so I just picked cold was the opposite of hot. Maybe mild is the opposite of spicy. C is an if then, it's a conditional. But remember, when you negate a conditional, you get an and statement. So if you eat raw chicken, then you will get sick. The opposite of that is the instance where that is false, where it's a lie. And so you would say that's a lie if I ate raw chicken and I didn't get sick, right? So you just, the if part becomes the first part of a conjunction, the first part of an and. So it's P and not Q, right? You can see that D says no two snowflakes are alike. So this is like for all snowflakes, there aren't two alike. This is a universal or a for all statement. And when you negate a for all, you get a there exists. So the opposite of no two snowflakes are alike would be that there exists at least one pair of identical snowflakes. It doesn't mean that all snowflakes are alike. That's not the negation of it. The negation is everything outside of this category. And so if you could find a pair of snowflakes that were identical, then you would say, hey, this is not true. E, there exists a number that is both odd and even. So this is an existential statement. And to negate that, you get a for all not. Remember? So we could say, for this not to be true, to negate this, we would say no numbers are both odd and even. So for all not. For all numbers, none of them are both odd and even. That's the opposite of there exists. So make sure that you can handle those kind of negations. Also, we got to make sure that we can take and make a truth table to show things like a statement P implies Q is the same thing or logically equivalent to its contrapositive. Remember, that's when you flip the P and the Q around, but negate them both. And it turns out that, yeah, they are the same. Because if you take and make your truth table, this P goes to Q column is true, false, true, true. And then the not Q goes to not P column has the same truth values. And notice I made a note that these match. And since you have the same truth values in matching columns, the column headers are logically equivalent. Make sure that you know how to find when a conditional is false, right? If P implies Q, then the only time that's false is when P is true and Q is false. So I'm looking for this true-false pair. P is true and Q is false. And that's the only instance where P goes to Q is false. So make sure you can do that. Let's also make sure that we can use a truth table to show that an argument is valid or not valid. Now, I actually thought I was doing you a favor on the test because I gave you two premises, but you really just needed P and not P. There was not even a second statement. It was just P. So P could be true or P could be false, but this was only a 2-row truth table because we've got P, we've got not P. We got to make sure we have a P or not P column. But look, P or not P is a tautology, so it's always true. So you see that this is true, true. And then our second premise, not P implies a contradiction. Well, a contradiction is always false. So if you go down here to this column, not P implies contradiction, remember this is a conditional statement, and conditional statements are only false when the first part is true, but the second part is false. But this is always false. So I'm looking for not P being true, and the contradiction is false. So not P is true right here. And of course, that leads to the contradiction of false, which means that the statement is false here. But this statement right here, not P goes to contradiction, is vacuously true right here. And that sets us up to have a critical row right here, this first row, because premise 1 is true, premise 2 is true, and then the conclusion is P. So that's the conclusion. I put P right there. And you can see in that critical row, the conclusion is true and the premises are also true. Therefore, this argument is valid. This one went okay. Number 5 went okay. I'm not going to talk through that one, but you can look at my answer. Number 6 did not go that well. So let's take a look at number 6. We've got 4 premises, and we're trying to create a connection. We're trying to write some more steps to get down to a conclusion of R. And it actually took me 5, 6, 7, 8, 9. It took me some more steps to get there. So how did I take all these things and the laws that are available to me to make connections between statements and get to R? Well, I noticed that not Q was true in 4, but I also noticed that Q or N was true, but Q isn't true. That means N has to be true. So that's the disjunctive syllogism on 3 and 4. You can see I'm just saying N is true. And I'm mapping that with the name of the rule that let me do that, and then the 2 lines that I use to put together 3 and 4, because Q gets eliminated in 4 and N is left. Then I was noticing I'd like to get to P if possible, but I need N or O, and I already have N, and I know I can attach something with an OR statement for free using the addition property. So I just added an O here, N or O, to line 5. Now that I've got N or O, that's line 6, this premise N or O goes to P allows me to say P, because I got to N or O right here. So modus ponens allowed me to go to P using line 6 and line 1. And then I wanted to get to R, right? So, but I have P, which means I also have P or Q. So I had to say I have P or Q, right? That's addition. And once I've shown that I've gotten to P or Q, then I can travel to R using modus ponens again on line 8 and line 2. So make sure that you can handle that. I guess the middle of this test was kind of the meat of the test. You will have to do one like 7. Which of the following candidates, A, B, C, and D, relative to target D, are not necessary and not sufficient? And the way our author handles this, the necessary and sufficient conditions are whichever ones are outside of not necessary, which I got A, B, and C. The only one left is D, and so he wants us to put that as the necessary condition. So whatever you get for not necessary, then the opposite is in the necessary. But like we said, and like you probably wrote down here, there might be other categories that the target is being affected by that aren't being measured in the table. And the author is kind of saying everything in the table is the universe of possibilities. So it's kind of lame, but whatever you get here, A, B, and C, the opposite or the other is down here under necessary. And when you get B and D here, the opposite, A and C, is on D. Now, how do you get that? Which candidates are not necessary for G? So I go down to where G is happening right here, and I say, well, what isn't happening? See, A is not happening when G is happening. That means A is not necessary for G. But down here, G is happening, and A is not happening, B is not happening, C is not happening. So these 3 things are not happening, but G is, which means A, B, and C are not necessary for G. So that's how we got line A. How about this? Which candidates are not sufficient? So that's where we look at G not happening and we say, what is happening? So like D is happening, but G isn't. And sufficient means if D was sufficient, then D alone being present would be enough for G to happen. So since G is not happening, but D is present, D is not enough to make G happen. So D is not sufficient, nor is B. B is happening, but G isn't. So B can't make G happen because B is happening and G isn't. And that's why we see that B and D are neither sufficient to make G happen. Surprisingly, I was actually pleasantly surprised that Knights and Knave problem was handled pretty well. So good job on that one. I thought this was by far the toughest question on the test, or one of 2. The other one was only worth 2 points. And so you can see what I wrote down for my argument that it concludes with B being a knave, A being a knight, and C is a knight. But I thought that was pretty tricky. Liar, Lord, Lunatic, I thought that would be just a gimme. I thought that would be totally easy. I don't know. Some of you thought a little differently than me, and you had good maps, and I gave you full credit, even though it didn't quite match my map. And some of you had no idea what to do there. I just figured since I did it in a lesson, and since we had a whole chapter on it in More Than a Carpenter, it would be an easy thing. But you know, sometimes I'm wrong about stuff. The Bible verse, I was pretty lenient on that. Essentially, it was transitivity. And if you oversimplified it a little bit like I did here, I still gave you full credit. So you can look at that. Some basic probability questions. For the most part, that went okay. And you can check your answers here by looking at my screen. The one question that was actually pretty tough was, and I gave it for free if you were in the right direction, but the probability of pulling a card from a deck and then a second card and getting not an even with the first pull and then a queen with the second pull. The tricky thing about that was if you didn't get an even, you could get a queen, right? And not getting an even, you could get a queen with the first pull. And then the second pull kind of wonders, well, did you get a queen with that first pull or not? And so the way you have to calculate that is you say, well, with the first pull, it could be no even and no queen. And there's 28 cards in that category out of 52. And then that leaves 4 queens on the second pull out of 51. And of course means times. So you multiply those together. But then there's another way actually for the outcome that you're looking for to happen. And that is No, no even, and a queen on your first pull, and then a queen on the second pull. And that would still be not an even. If you got queen, queen, you'd not get an even. And then you get a queen. So this is the queen, queen scenario. You have to add them together because that's an or. But this was only worth 2 points. And if you started out toward the right answer, I was pretty lenient on that one. I thought actually number 12 went really well. People were well studied on that for the most part, and it worked out good. So you can check your answers there. And the fallacies, there were some that I was kind of lenient on, but I thought that went mostly okay. And of course, if you really didn't study and you weren't prepared, you know, it didn't go okay for you. And some of you were in that category. But I think you probably knew going into the test that it wasn't going to go well, because it was pretty clear that a lot of people really studied hard and it was still a good battle. And then some of you just kind of didn't engage much. And so you did miss a lot of points. But you can still make up the 25 points, and that'll help. Everyone can. So I'll just give you these solutions here. I think my favorite one of these was, let's see, which one was it? This one. And the sign by the pond said, fine for swimming. So I dove right in. And I had to think about that one. It's like, wait a second. Of course, it seems like it's okay to swim, right? But if fine means I'm going to charge you money because it's illegal and you shouldn't do it, then, then you shouldn't dive in. So that's equivocation, where we use different definitions for the same word. So I thought that was kind of funny. And a few of you memorized the scripture, which I really appreciated. So thank you for that. All right, friends. Well, we're going to get back on the horse and we're going to do good. You know, sometimes things can just be a little bit disappointing, but I think this is the truly gracious response, to try to help you learn some things and give you a second chance to make back some points. And just get online and sign up for a slot. Do those 5 questions to qualify. Come in and meet with me, and then we'll have you take that 5-question make-up points test. And this week should actually be pretty light in terms of the class. Monday, we're talking about the debate project, and Ron Mock will be with us from the civility project, so that'll be interesting. And then we were talking about the Fibonacci's on Wednesday and Friday, so that's a little bit lighter and just interesting math, kind of edifying, fun little play games. And Neil's going to take those too, so I'll get a little bit of a break here. But I love you all, and I'll look forward to seeing you soon.